All right, good morning, POE. This morning we are going to cover from Unit 2.1, centroids. So if you go to modules on Canvas at your own time, you'll be able to find what I'm covering today. There's a PowerPoint, which I'll be opening. There's a PDF version of that PowerPoint, but I recommend that you watch the PowerPoint version if possible because it has some animations that help make it more clear. This is a link to stuff in your mypltw.org textbook, and then 2 sample videos from YouTube that you can also use to assist you. Okay, so with that, let's get started with our PowerPoint for today. Okay, and so centroids. Centroids, obviously here it says, is the object's center of gravity or center of mass, and it's labeled with that label right there. So basically, it's the balancing point of any object or shape. Okay, point of applied force caused by acceleration due to gravity. So gravity's pulling down right now on this weight, okay, and the object is in a state of equilibrium if it is balanced along its centroid. So equilibrium just means that something is balanced, right? So static equilibrium would be that all of the forces pushing down are equal to all of the forces pushing up. And so it's not moving. So if you have a water bottle and you put it on the table and the water bottle weighs 1 pound, it's pushing down on the table with 1 pound of force. The table is pushing back up with 1 pound of force. So we have negative 1 pound of force, right, going down. The table's pushing up, that's a positive 1 pound of force. So negative 1 plus positive 1 is 0. So there's no total force, right? And we can understand that because the bottle's not moving. So here, if we look at the picture on the left, we have a 25-pound dumbbell, and he has his finger in the middle of the dumbbell. So it's balanced, right? So the amount of force pushing down on the right side and the amount of force pushing down on the left side is equal. So it's not going to spin around his finger. It's going to be balanced. Whereas here, it would be unbalanced, right? This is not the center of gravity. You can imagine that this would tip down, okay? So what is an object's centroid location used for? Okay, so theoretical calculations regarding the interaction of forces and members. Okay, so basically, the centroid location is something that a designer would consider when they're thinking about like the tipping point. So a race car has a very low center of gravity, and that's so that it can go around turns very fast and not tip over. Whereas a Jeep Wrangler, especially if it has big wheels on it, if it goes around a turn very fast, its center of gravity is very high. Most of the weight is very high off the ground, so it has that it's easier for it to tip over. Okay, so similarly in football, they'll often, or wrestling, they'll often say like get low. You want to be low because it's hard to push something over that's low to the ground, where if something is very tall and standing up straight, it's very easy to push off balance. So that's kind of where they tell you like bend your legs, bend your knees, get low to the ground. Okay, so symmetrical objects. Okay, that's mostly what we're going to focus on here. Triangle, squares, rectangles, circles, and semicircles. So the centroid is always, right? The center of gravity is always in the line of symmetry. And that makes sense because even if we go here, I could draw a line down the middle of this, and that's our line of symmetry, right? This is a mirror image of this. So that's the balance point. So here we have a line of symmetry. The line of symmetry runs up and down here, right? On the y-axis. So we could say that the centroid is somewhere here on the y-axis. When it has multiple lines of symmetry, it's located where they intersect. So here we have a line of symmetry here, right? If I divide it into a diagonal triangle here and here, I could also say, well, I could go straight across and I could go straight up and down, and it would be lines of symmetry. And then on a circle, any two diameters, right, lines that cover diameters, any two chords that make up the diameter would be intersecting at the middle of the circle. Okay. So how do we calculate? So basically what we're looking for is the location of the centroid x and y coordinates. So that's kind of what we're finding here, x and y coordinates. Okay, so let me give you a little bit of notes here. So really, when we attack this, okay, we want to say that x with a line over it is equal to the distance along x-axis, or the x coordinate. And y distance along y-axis, or the y coordinate. Okay? So that's basically what we're trying to find here. So when we look at this PowerPoint, what we're trying to find is, if I were to give you x and y coordinates, how far, that's where the center of gravity would be for this object, okay? So for a square or rectangle, it's a really easy formula. You take the base divided by 2, right? Because that's the line of symmetry. If b equals 4, then the line of symmetry would be halfway, right? So this would be the vertical line of symmetry. If height is 4, then halfway up would be our line of symmetry, right? So we could cut it in half this way. So where they intersect is going to be our centroid. So its base divided by 2 is x, and height divided by 2 is y. Most common mistake here is the students will get these backwards. When we're talking about a right triangle, we have the centroid of a right triangle is located at a distance of 1/3 its height and 1/3 its base. So here we're going to use that the x location can be found by doing x divided by 3, right? I'm sorry, b divided by 3, and the height can be found, the y can be found by doing height divided by 3. So if this were 12, then this would be 4, and if this were 9, this would be 3. So our coordinates would be 4 and 3, and that would be the balance point of our triangle, okay? Now, there is an exception to this, which I want to go over really quickly here. So if I take this up here, right, that's the definition that we just got, and I shrink that down. So I want to give you where this is not always true. And I have y and x coordinates, okay? So I have a y coordinate and an x coordinate. And then on that, I have so if I have a triangle that comes over like this, okay, then basically we're going to have a slightly different rule. So let's imagine that the base here is 12 and the height over here is 9, okay? So 12 and 9. So a second ago, what we found was that when doing these calculations, that what we found was that x equals base divided by 3 and y equaled height divided by 3. Okay, so you say to me, well, okay, Mr. Cahoon, the x is, so that would be 12 divided by 3, so x equals 4. Okay, and then you say, all right, Mr. Cahoon, well, let's see, y divided by 3 is 9 divided by 3, so y equals 3. Right? So if I were to graph that, really, remember, we're trying to find the center of gravity of this shape. If I were to graph that, basically, I would get something like, okay, let's see. I'm going to go over 4, and I'm going to go up 3. And basically what we would be saying is, okay, so if I go over 4 and up 3, we're saying that here is the center of gravity of that triangle, that I could balance it by right there. And that just doesn't make sense because most of the weight of the triangle is over here. So here's the exception. When you have a triangle, when you do base divided by 3, the answer, so in this case, the answer of 4 needs to be marked off from the right triangle, okay, from the right angle towards 0, 0, okay, towards coordinate 0, 0, right? That's coordinate 0, 0. So we need to go from, so we take 12 divided by 3, and we get 4. So we're going to go 4 from the right angle. So we're going to start at the right angle, and we're going to go over 4. Okay, and same thing here. We're going to do 9 divided by 3, and we're going to go up the y-axis because so what we're going to do is we're going to count from the right angle. So from the right angle, I'm going to go up 3. Okay, so the question is, if this distance is 4 and this distance is 3, then what are the actual x and y coordinates? So if I started over here, right? So here's where our centroid is going to be, which makes more sense. It's in the center of the object, right? So if I were to start all the way over here at the x and y 0, 0 coordinate over here, better color. If I were to start over here, what would my coordinates need to be if I were to walk myself over to where the centroid is, right? I would walk how far along the x-axis? Well, if this is 12 and this is 4, then this is 8. So my x-coordinate is going to be 8. And my y-coordinate, right? So if I started here and I walked up to here, that would be 3. So my coordinates of my centroid are 8 and 3. So the key here is to remember that on a right triangle, when you do base divided by 3 and you get the answer, you go start at the right triangle and walk away from it. Okay, so let me give you another example. Okay, so imagine that we have y-axis, x-axis, and let's imagine again that we have a triangle, but this time I want to give you the example of, let's see, a triangle. Let's try a triangle like this, which is a really weird way to balance a triangle, but let's say that that's our triangle. Okay, so we're balancing this triangle. Let's see if I can, okay, guess I can't do that. And what I want to tell you is that the distance from here to here, okay, and from here to here. So I'm going to give you the distances, and I'm going to tell you that the distance over here is, we'll say 9, and the distance here is 12. And we'll also go on to say that the right triangle, okay, the right triangle is here. So let's do our coordinates, right? So we know that the formula is going to be base divided by 3. Okay, base divided by 3, and we know that y is going to be equal to height divided by 3. So let's start with the base. The base is 12. Okay, so 12 divided by 3. So this is going to be 4. Height divided by 3. Okay, 9 divided by 3. So this is going to be 3. But what I just told you in the previous slide is that on right triangles, right, on right triangles, when we find this, what we're finding is the distance that we have to go from the 90 degrees along the x-axis. So if I start here and I go 4 in this direction, right? And if I go, right, so that's going to be 8, right? It's 8 from here because it's 4 from here, okay? And then I'm going to go 3 along the y-axis from the right angle. So I'm going to go down, right, 3. Okay, and so basically, if this is 3 and this is 6, right? So what are the coordinates of my centroid? So if here's my centroid, my balancing point of that triangle, if I were to give you coordinates, what's the x and y coordinates? So if I start at 0, 0, I go over 8, and then I go up 6. So that's my answer. Okay, so if I were asking you for the x location of this centroid, you would tell me 8. If I were asking you for the y coordinate of this centroid, you would tell me 6. If I was asking you for the x and y coordinates of this centroid, you would tell me 8 and 6. Okay, great. All right, let's move on here. So we have some other shapes that we want to deal with. Okay, so here we have a semicircle. So the centroid of a 1/2 circle or semicircle is located at a distance. And here is the formula for that. 4 times the radius divided by 3 pi. Okay, 4 times the radius divided by 3 pi, and on the line of symmetry. So in this case, the line of symmetry is going to be right here, right? Right down here. So that means if the radius is 2, that the base is 4. So the line of symmetry is here. And then we use 4 times radius, 4 times 2, divided by 3 pi equals about 0.849. So I don't like that they rounded this, so let's ignore that and stay with 0.849, 0.849. So the line of symmetry, okay, and how high up we have to go. So let's do an example of that over here on the smartboard. Okay, so let's do, okay, so x and y axis. Let me see if I can get a semicircle. Okay. Okay. So I have a semicircle, and basically what we want to say here is that the semicircle is, so let's say that it has a base of 8, okay? All right, and it's a semicircle. So that's really the only dimension that you need, because if the base is 8, then that means the radius of our circle is 4, right? And if the radius of our circle is 4, then from the center of our circle to any point on the outside of that circle would be 4. Okay? So let's find the line of symmetry. The line of symmetry here, right, would be here. If I were to cut this shape along that line, as crooked as it is, it would give me a line of symmetry, right? It's two of the same shape. They're mirror images of each other. So that's our line of symmetry. So we have one of our centroid locations right here, right? So one of our centroid locations can be found by going 4 along the x-axis. So we know that here, x is going to be 4 because it's the line of symmetry. Now, y is going to be 4 times radius divided by 3 pi, which in this case is going to be 16 divided by 3.14, 9.42. Okay, and then 16 divided by 9.42, we'll say 1.7. So y equals 1.7. So we're going to go up 1.7. Okay, so we're going to go up the y-axis to 1.7. Okay, so our y is 1.7. Okay, and so our centroid is here. Now, similarly, we have some exceptions to this rule. So let's try an alternative. So what happens if I take my y and x-axis, okay, y and x-axis, and then I make a semicircle. So let's get a semicircle here. Semicircle. And let's say that let's see if I can rotate this thing here. Okay, let's see. Okay. Okay, so I have a semicircle. And now let's say that my semicircle, okay, has a distance here of, well, we'll say 12. Okay, then what is so that's the diameter. So then the radius has to be what? Has to be 6. Okay. All right, so let's find the line of symmetry here. Well, the line of symmetry here is no longer going this way. Well, this line of symmetry is going to go this way. So how far up do I have to go on the y-axis, right, to get to the line of symmetry? So, right, so 6. So 6. Okay, so basically here, what we're saying is that the line of symmetry is this time is going to be my y-coordinate, and it's 6. But what about the equation? So we have to do 4 times radius divided by 3 pi, and we're going to get 4 times 6 is 24 divided by 9.42. Okay, 24 divided by 9.42, and we get about, say 2.55, just round it. Okay, and so we're going to go out 2.55 here. And our line of symmetry is going to be here. So it's 2.55 from the base of the semicircle. From the base of the semicircle is important. So here my coordinates would be 2.55 and 6. Okay, 2.55 and 6. So if I go out 2.55 and I go up 6, I will get to the center of gravity. Okay, I want to do one more. So let's do one more here. I'm going to really try to trick you. So basically, we'll go here and here. And I'm going to take my shapes. And I'm going to make a semicircle again. Except this time, I want to rotate it this way. Okay? Okay, so this time, I'm going to tell you that we have a height of, or a diameter, I guess, of 10. Let's make it 12. 12. And that makes our radius 6. Okay, so here, let's do our first piece, which is, where's our line of symmetry? Our line of symmetry is about here. Oh, that's a little bit off, so let me back up. Okay, so it's about here, right, which is a distance of how far from 0, 0. So if I start at 0, 0 and I go up to get to that line would be 6, right? 6. And then I need, so which coordinate is that? That's y. So of my two coordinates, I know that y is 6. But to find the other one, I need to do 4r divided by 3 pi, which equals 24 divided by 9.42, which we said was about 2.55. So you say, well, Mr. Cahoon, it's 2.55, right? So I just put 2.55 up here. No. What you need to do is start at the base of your semicircle, and along the x-axis go 2.55 towards the shape, not away from the shape, because your center of gravity can't be out here. It can't be off the shape, right? Your body's center of gravity is not like 4 feet away from you. It's somewhere on you. So the center of gravity has to be somewhere on the shape. So we're going to start at the base, and we're going to go in 2.55 towards the shape. So terrible straight line. But basically, our centroid would be here, okay? But the question is, if this is 2.55 from here, right? This here, let's see, if this is 2.55, then what is this amount? Well, 6 minus 2.55 will be 3.45. So from here to here is 3.45, right? From here to here. So the coordinate would be 3.45, okay? So the key here is to remember that on semicircles, when you use this formula, you're finding a distance from the base, count towards the shape. Okay? So we start at the base and we go 2.55 in. And then the other thing to remember would be for right triangles, right? For right triangles, that when you use this equation, when you use an equation, you have to always count from the right angle, And so, right, it's from the right angle. So this distance is the distance towards the shape from the right angle. This is the distance towards the shape from the right angle. Okay, and similarly, okay, when you found this, it's the distance toward the shape and the distance toward the shape, Okay, we'll stop right there for today. That's simple. That's slides 1 through 9 on the Centroid PowerPoint.